BIM actually is building information modeling. Building information modeling, as the name says, it's building information and a model. You have a building, you have few information about it, you feed the information into a software, and in turn the software gives you a handful of information. What you do in the software is a model actually. To give an example, I can say like a wall, you have a 30 feet wall, and in that 30 feet wall you have a door, 3 by 7 door, a 4 by 4 window, you have 3 columns in between, and you have a roof attached to it, a floor attached to it, and you have plaster thickness, you have a painting area, everything is there. So much of information I know about a particular wall which is 30 feet by 10 feet height. I feed this information into a particular software, and the software in turn gives me the number of bricks to create that particular wall, and the wood that is required for the window and the door, and the amount of cement that is required for the plaster, the flooring and the roof. So a quantity of material is arrived. So when you have the quantity of material in hand, what happens is you know the amount of labor that is required and the time taken to acquire the material, and then the time taken to complete the 30 by 10 feet height wall. So all these information you can extract from that particular software. So it is like you just have a few information, you say it is a 9-inch thick, 30 feet and a 10 feet high, you have a door, you have a window, you have 3 columns. That is all the information that you have, which in turn you get so much of information back into your hand. So that process of working with a little information by creating a model in the software and getting back a few information in hand, that process is called building information modeling, which we call it as BIM in short. So this process, it is a process, it is not a software, it is a process. So building information modeling is its elaborate. Okay, I'm architect Lydia, and my native is down south, Tirunelveli. So I came here to study about architecture, and I came here in 2001. So 2001 to 2005 I did my architecture in Dr. MGR Engineering College, and I started pursuing architecture as a profession after 2005 and under the name Lebon Architects, and till date I have been working under the name Lebon Architects. And 2018 I passed out in my masters from Miyasi Academy of Architecture, and from 2009 I have been like working on small residences. And to talk about me, I come from a background of family where we are civil engineers and architects, and so we work together as like we do the designing, myself and my sister, we do the designing, and my brothers work it out at site. So that's how we have worked out, and we operate under the name Lebon Architects and Lebona Interiors. BIM process, as I said, is your work as an architect first. Second, a contractor's work at site. Third, it's the facility management. This is the process. The people at site, they have already embraced the project management stuff. They have embraced it long back, and they are effectively using it actually. The facility management also is effectively using the facility management softwares like to a 90 to 100%. Construction management, they are using it to 100%, whereas architects, we are lagging behind. we haven't embraced this process yet. If we start embracing this process, we save on time, we save on money, we save on so many aspects of our professional life actually. Like the effort that you put in your particular project, like when I draw a wall, I can draw it along with my sections and elevations. I'm not drawing it only on 2D. I'm doing it on a 3D environment. So what happens is like I build it as a building so that wherever I can take a section, I can do it. I just have to click a line and view it. So that is how it is. But what happens is we haven't started working in that manner. And also in this particular process, what happens is I correct it in one particular floor plan, it gets corrected everywhere. It gets corrected in the section, it gets corrected in the schedules, it gets corrected in the material takeoff, it gets corrected in the 3D view. So you save a lot of time there. Basically what happens is we are afraid, we don't come out of our comfort zone. We are so comfortable using a 2D software, so that we don't come into this Revit, or we don't use a 3D combined software to work in our drawings. So what happens is a fear of losing time. I am very much well versed with this AutoCAD. The time that I take to create a floor plan is much lesser than what I can do on this particular tool. So what I do is I don't work out now, I'll do it later, I'll do it later. So that comfort zone of us makes us, and the fear that we have in embracing a new tool brings us at this state. So what a person can do is, apart from the time that they have, they can work out on these particular softwares little by little, and then get into this as a full time. Another thing is, like in the industry, the corporates are paying much more when they have BIM. Working in the BIM environment pays more than working in a normal environment. The fees for a normal environment is much lesser than the fees for the BIM environment actually. So the difference is huge, 5-8 times more than what you receive as a beginner when you come out of architecture colleges. If you know what BIM is, if you say I am a BIM architect, I know what is BIM, I work on BIM environment, if you say that and if you go to a company, definitely your pay is more than what you receive as a very ordinary architect in the beginning. So as you go, you grow. As the company grows, you grow. So your pay grows along with that. That is the difference that an architect who is having a BIM experience, an architect who doesn't have a BIM experience. We have a building to work with. So the number of people associated with working with the building is, you have architects, basically the client, then you have the architect whom the client picks up to work on that, and then you have a structural engineer, electrical engineer, MEP consultant, you have structural consultant, then you have a contractor who is working at site, you have the site engineer, you have different various contractors, you have different people working on it. So when we work with different people, everybody can work together as a process. This process is actually a collaborative process in which we unite together to work for the peace of mind. To exactly explain this, I can give you an example. Like when we do a traditional process of designing, first the architect designs it, then we send it to the structural engineer to get a structure done, then we give it to the electrical engineer, then we give to the mechanical person and the plumbing person to give a design, and we get it back. How many of us incorporate everything together to see whether everything is clash free? Most of us don't do. We just say this is free of any clashes and we give a good for construction drawing. But what happens is, at site we face many difficulties. The mechanical, electrical, plumbing engineer, he complains about the architect, he complains about the structural engineer, the structure is too big, I am not able to route my electrical line. The architect didn't give a proper drawing, he has to verify it, he hasn't verified it. So all these clashes happen at site, and it is too late for us to understand and get a solution for it, because our structure is already there, the electrical line is halfway through, the plumbing line is halfway through, you have a loss of material, you have loss of money, you have loss of labor, and finally it's your loss of peace of mind. So when you lose your peace of mind, automatically like 1 or 2 days you get mind blocks in working with the project and stuff like that. When you have a person who is always scolding and shouting at you at site, normally it's due to all these loss of labor, loss of material, loss of money. So to avoid all those things, we work that project in the virtual platform and we build it as we build it at site, and find out that this particular building can be done clash free, and it is like I can do it in this many days with this many labor and this many material, and I can finish it in this particular date against all odds. So with this clarity, when you start a particular project, it becomes a fruitful one actually. To clearly talk about it, when you have a clarity with your project, where the lines are, where the plumbing lines are, where the electrical lines are, when everybody has a clarity about it, everybody works together harmoniously. So that is the main criteria when we work with BIM. So everybody can collaborate and everybody can work with peace of mind. We have a lot of softwares, with this. This is a process, and for each process we have different softwares. So basically when you do a schematic drawing, we work with Revit, software called Revit, which is from Autodesk, and we also have different softwares. We have ArchiCAD. So these softwares help us in doing the basic drawings. Then we have a software wherein we work out the structural analysis. If we see from Autodesk, we have robot structural analysis, STAAD Pro we work that out and then bring it inside this particular software Revit, and we can incorporate that those details into this software. And then we have our mechanical, electrical and plumbing details. We can do that in Revit itself. So all these drawings, construction documentation, everything is done in Revit, and then you take it to Navisworks, a software from Autodesk, where you get a clash free environment. So if I have a particular room where all my lines are running, I can run the model into this software and I get a clash free environment there. And from there, with all the details I get from this, like the material, the labor and whatever details I get from this particular Revit, I take it on to the management softwares like MSP and Primavera and work out the management stuff there, the project management stuff there. So you manage the software right from the beginning to the end. So people who work in our civil engineers, structural consultants, and then you have interior architects there, you have mechanical, electrical, plumbing consultants there, then you have your mechanical, electrical, plumbing contractors there, you have civil contractor there, you have facade engineering contractors, facade designers, then you have firefighting safety designers there, you have the firefighting contractor there, So all these people can have an overview of your building even before it was built in real time. So the virtual environment gives you a clear idea of what is going to come on site even before you dig a pit for it. So that is that process. When you finish this process, you know, okay, this is the end product, this is how I am going to do. It's like a prototype that you are building for your building. The first project that I did was a 800 square feet residence. So the 800 square feet residence was like in one floor, one and just a single room or a single bedroom on the second floor. So ground floor and first floor, I had all the details. The client finalized all the details. I took it to the contractor. Contractor was giving me a material support. So we had a material list. So all these are the materials that is necessary, and I gave him a material list. So this is what are the materials that has to be used for this particular project. So when we came into a conclusion that whatever I had taken from the software and given it to the contractor and whatever he has arrived at, both are 95% similar. So that is the 95% is like 5% he was at the higher side because he was taking into account all the wastage and stuff like that. So the 5% was on the higher side for him. So the similarity is that when you know actually how much material is required for that, you easily calculate how much of labor and how many days it will take for this particular project. So we worked together in, we didn't go for a management software at that time. We worked together and we laid out details on how much of work, foundation, how much of days it will take, how much labor it will take. We started working in that manner. So for the foundation separately, then for the plinth area, plinth beam and stuff like that, the next stage. Then the column, how to raise the columns, and the brickwork stage was the next one. So we started working like stage by stage, because when I get the quantity takeoff from the software, what happens is like you get quantity at stages. For ground floor I have so much of bricks necessary, for first floor I have so much of brick necessary. So you get it in stages. So that particular information you can feed it into your particular software that is used for management, and you can work it out there. So that process made things simpler and easier, and the client also knew how much of bricks that we are buying in numbers, how much of sand that we wanted in numbers. So all that was very clear and transparent for both the contractor and the client, as well as an architect. It was easy for me to certify the building at the completion stage, to transfer the amount from the client to the contractor. It was very easy because everything was transparent and everything was like, it was like on white paper. Everything was given on white paper on a platter. So it was like everybody can look into it and say, okay, this much of this quantity was required, this is used there, and there was very less amount of wastage. Because like in most of the sites what we see is like, if we need 5,000 bricks, we order 6,000 bricks for a safer site. That is what we do it. But here it was like not even 100 or 150 bricks went as a wastage. So when you buy good material, when you have the quantity of material in hand, you get this process right actually. It is not similar. Project management is a part of BIM. Like how you
schedule பண்ணனும்ங்கிறது project management வந்து
designing. As an architect you design. Designing is the first process. The second process, you document it. Construction documentation, that is the second process. The third process is you are managing the software, managing the project. So the managing the project la varumbodhu, you manage money, you manage people, you manage time. So project management is what that sits in the third process. Then final process is like facilitating the building. You rent it out to people or you use it. When you talk about facilitating, you do automations. So for that, it helps you out in BIM. This process is called BIM. Designing, documenting, then you have managing and facilitating. This process is called BIM actually. So you can't take out a process and say I am doing BIM. You can't just take out this documentation process and say I am doing BIM. It's not like that. You combine it together and work it as a process and you call it as BIM. Otherwise it is designing, documentation, project management, facilitating. That is the key. You can't take it out and say this is complete BIM. Only when you work out all the four, it becomes a complete BIM process. So the first one is building. Building is, as architects, we all know what a building is. Building has a heart and soul when you start living inside the building, and to make it viable for us, you do the drawings, you design it, you make the space viable for us to live in, and then with a few information that you have in hand, you enable others to work in it and you facilitate it for a person to occupy and live. So that is building. And information is like whatever information you have about a building, and model is whatever you view. I viewed this building as such, it has come out. So that is what is building. Basic, to understand the basic of building information modeling phrase, this is how it goes. But to understand it technically, you can listen further and you can understand it more technically. So to talk about what we are going to talk is like the first traditional process that we are following, what are the difficulties that we are facing in the traditional process, and then we will talk about how to ease this process using BIM process. So I am going to talk about traditional and BIM process. So what is the traditional process is, we have a client asks an architect to do a basic drawing. So what happens is, when an architect is asked for a residence plan or an office complex plan, he starts working on it by designing the whole building. So in this traditional process, we design it. Normally we do it by sketch or we do it by hand drawings, and then we go on to drawing, visualizing it, and finally when you build it at site, you visualize it as a reality. This is the traditional process. But whereas when AutoCAD came in, what happened was your hand drawings were eased. So you need not redo the whole floor plan of 10,000, 12,000 square meters again and again when you make a single mistake. So AutoCAD made it easier for us, and that was the ease we received from digitizing it. So and yet again it's a traditional process, it's not something that we didn't stop, it was again a traditional process. We have to do the drawings, we have to give it to our consultants, they mail it back to us. Structural consultant mails his structure back to us, an MEP consultant mails his MEP drawings back to us, and then a firefighting, if you give for firefighting, the same person mails it back to us. We coordinate it and issue a good for construction drawing to site, and this work is done. Whereas in the BIM process, what happens is, this digitization in AutoCAD has got a little bit of enhancement, and that enhancement is in the form of a model. You draw not lines but walls, you draw You don't keep a block for a door, but you draw a door. You don't keep a block for a window or your plumbing items, but you keep a real-time plumbing fixture there. You keep a real-time window there. So what happens is like when you visualize it in the 3D environment, you get a better idea about how the space is going to be for usage. So this process has made the traditional process much easier. So what happens is building information model. Building, information, you have information. When you see it as a model, you get a better view, a better understanding and better feel about the particular space that we have designed. Okay, so coming to this traditional process, I was talking about exchanging the drawings with a contractor and exchanging the drawings with a consultant. So what happens, what are the difficulties that we face while doing this is, when a client is there, we give client a drawing, we make minor corrections. Sometimes we forget to say the client that we have done a minor correction here. Then we pass it on to the structural engineer. Structural engineer comes up with his structure. Still we haven't updated the client because we forgot to send the email. Then we go to, we send the same drawing to MEP consultant. He reverts back. Still we haven't updated the client. Okay, after this process we remember we haven't updated the client. We talk to the client. We come up with a revision. He gives another idea, he says I want it this way. Then we have to go back to the structural consultant, get his approval. Then we go back to the MEP person, get his approval. Now after all this is done, have we updated it? We haven't updated it at the site. Work is already happening at site. In the meantime, this process is happening at the office. You delay it by 1 day to send it to the site, the work is already done at site. So what happens is the coordination gets messed up when you do in the traditional process. So these things can be avoided when you embrace this particular process called BIM. Okay, and I would like to give you a phrase which says, this process is not a single person's process. It's a process where you collaborate a number of people. Number of people in the sense you collaborate even the client to work with. Client in the sense there are investors who invest in certain buildings. So you call the investors, you call the client. A person may have a land, but his building might be invested by somebody else. So all these things put together, you collaborate together. The person who gives money will ask how much money is being spent. He can see how much money is being spent. The client can know how much money he is receiving from the investors, and the contractor will know, okay, this much amount I am receiving, so in this amount I have to build this particular building. So all these, the transparency between a client, an investor, an architect, interior architect or a structural consultant or a contractor, the transparency that we have when we work on this process is more than what we had on the traditional process. So this is the major benefit that we have, which is called collaborating with people. You can't say I am one man show, I do a one man show, I decide on all the factors that is related to the building. Even the client doesn't have a say, you can't say that. Everybody knows what it is. Today when somebody is building a house, more than we give them suggestions, they come up with 120 suggestions. So everybody is like educated. If they build one house, they feel fit to build 20, 30 more houses than the person who finished B.Arch, M.Arch, MBA and come out. So it is like everybody has a knowledge. Exactly. They go through Pinterest and have 150 pictures for one particular element that they want at home. Exactly. Or I had a customer who said, I want this window, I want this door, I want this courtyard, I want this size of room, I want this interior, can you assemble it for me? He has given me everything. There was no need to design. I had to just jumble the space and finish it. So it is like more than us, the customer is educated more. So what happens is you need to be more effective than the customer. He knows 20 things, you know 100 things. That's how it should be. So he technically doesn't know how to place which element where. So that is the challenge that you have to identify, and that is the challenge that you have to give solution for. So when you give solution to that particular difficulty that he is facing, that's why he has come to you, and when you give a solution to it, he is satisfied. So that is where architects and engineers play a major role, and this process BIM helps you in that particular aspect of helping him do the 80% that he doesn't know. So the next one is we'll see about the 3 M's of BIM. 3 M's, building information modeling, the last part, M. So we have 3 different things on that. One is a model, another is modeling, another is management. So model is what you create in the software. You create a wall, you create door, windows, that particular model. Without a model, you cannot go through this process. So to create a model, you have to understand what is modeling, or what is the third dimension, you have to understand that, and you have to work on that. So to create a model, you need to understand modeling. So model, modeling and management. You need to know when you do it on the real time, how you will manage working out that particular wall. So that particular management comes under M, the 3 M's of BIM. Okay, and then we have the principles of BIM. What are the principles of BIM? We have different levels of working with BIM, and then we have we call them as level of development. So we have from 100 to 500, we have 6 different levels of development, and then we have the dimensions: 2D, 3D, 4D, 5D, 6D, 7D and 8D. So we have so many dimensions to BIM. 2D is your 2D construction drawings, 3D is your visualization part, and then you have 4D, 5D, 4D is your time, 5D is your cost, and then 6D we call it as sustainable. You do energy analysis also with this software, and then 7D is your facility management, and 8D is your safety and security. So this is how it goes, different dimensions of BIM. So normally as an architect you work with 2D, 3D. As a project management you work with 4D, 5D, 6D. If you are like working with sustainability, then you work under 6D. When you facilitate a particular project, you work with 7D and 8D. So that is how the process goes on. And the level, we talked about the level of development. So we have different levels of development here. The first level is like LOD 100, where we give a basic schematic drawing. LOD 100 is basic schematic drawing. I can give you an example with a column. I say this particular column comes in the porch area, which is a 9 by 9 column. I haven't described it as a it can be a square, it can be a rectangle, it can be a circle. I haven't given a dimension to it. Say like I haven't given it is exactly 9 by 9. I haven't said it is a 1 feet 3 inches by 9. I haven't given it any dimension. I am just telling there is a column in this particular point. So I just say that kind of schematic drawing it is, the LOD 100. And then LOD 200 is I give it a dimension. I say this particular column is round column and it has a diameter of 300 mm. So this is the second portion that I am giving. And then LOD 300 is, I give a more detail to it. I give a little more detail to it. I say the column has a order on top, Doric order, it comes under the Doric order column, or it comes under a Corinthian order column. What is the more detail that I can give to the column? So little by little in each and every stage you add different details to the column. So when you go from LOD 100 through LOD 500, LOD 500 is your final as-built one. LOD 400 is your detail drawing. You give each and every detail of that Doric order or Corinthian order, whatever detail you have on the column. So this kind of development happens from LOD 100 to LOD 500. So you document each and every detail that is pertaining to that particular column in different stages. So this is the process when you work out as an architect from the schematic drawing to the as-built drawing actually. So finally what I would like to say is you have different softwares that help you to work out in BIM. To start with, we work with Revit, which has a 2D and 3D environment, and then there are different softwares for that particular process also. You have ArchiCAD, you have MicroStation, you have different softwares for that. Then you go on to clash-free environment, which gives you clash detection, which can be done under Navisworks from Autodesk again. And then there is another parametric modeling software called Rhino, which also helps in this process. And then you have a quality analysis software, which is Solibri. That is a quality analysis software. And then you have project management softwares, MS Project and Primavera. So whichever, there are n number of small time startup IT companies that are coming up with different softwares that can help you to work out in BIM. There was one which was recently brought to my knowledge, Snaptrude. They are working out, they are a small time beginners. So they are working out an environment that will help you to compete as you can do it in Revit. So there are n number of softwares. We have to choose the right software for the right environment, for the right project, and work along with whichever software that can be easy for us to work with and handle it. So that is what is the biggest challenge. So to start with, if you learn a software which talks to you in your own language, say when I talk about Revit, Revit is kind of like, I talk about it very passionately because it talks to me in my language. It talks wall, doors, windows, floor, roof, ceiling. It doesn't talk line or spline or P-line. It talks to you as wall, door, window. When somebody converses in that matter, it becomes easy for us to understand and elaborate on that more. So that is where I was more passionately affiliated and attached to the software Revit. The same thing with the ArchiCAD also. That software also talks to you in wall, doors and windows. So it becomes easy for the person who work as an architect. If you are an architect or an engineer, it becomes easy for you to work on that environment rather than working on lines and splines. So choose the software which is best for you, choose the software which is easy for you to use and start working on it. So that like you start the process, you get into it one by one, and then you start embracing the process as a whole. The first thing is when you have to learn about BIM, the first thing I'll say is learn the tool which helps you to work on BIM. Understand the process. you have to understand what BIM is, understand it as a whole process, then understand which tool is used in which part of the process. If you say schematic drawing, understand the tool that will help you for schematic drawing. If you say 3D, 2D, 3D, understand which tool will help you for a 3D. You can create your model in Revit, take it to Lumion, you can take it to V-Ray and render it there. And you can also take it to Twinmotion. You have different softwares for rendering. So you can render it there. That process also comes under this BIM actually. You do a 2D, you do a 3D, visualize the 3D here, you can do a 360-degree visualization, and when you want to present it, you present it by rendering it in a better software. So that is also a process. So understand which tool will help you. So understand that tool and learn the tool. When you learn the tool, the process becomes much more easier. So for management, if you have to manage a project, understand which can help you to facilitate and manage the project much easier. If you find Primavera is very hard, go with MS Project. If you find MSP is very hard, go with Primavera. Whichever is easy for you to understand, embrace that particular tool and go ahead. So the course model that I am offering is like, I go with the tool Revit and Navisworks. So with Revit I teach all the tools, the interface and all the tools associated for you to make a 2D plan, a 3D a visualization out of it, and you can get a list of materials that is necessary for that particular project. So I'll teach all the tools that is for me preparing a particular drawing. In the sense like you have like we call it as blocks in AutoCAD, door block, window block. Here we call it as families. We create them as a 3D model. We create whichever design that we want, we create them in a 3D model, and we attach parameters to it, and we use them in different projects. So all these things will be taught, how to prepare 3D blocks, how to prepare a documentation, how to prepare a construction documentation drawing, and how to give it as a final product to the end customer. Basically all the softwares are heavy. All the softwares are heavy. Revit by itself is heavy because Revit is a single file software. It's not like when you work on AutoCAD, that is a major difference that you find from AutoCAD and Revit. When you work with AutoCAD, you have first floor plan, second floor plan, third floor plan, ground floor plan, sections, elevations, 3D views. You have 10 files for that. Revit is one single file. You will be browsing through the different floor plans within that one file. So the software itself is heavy. So you will need a better system to work, hardware to work on that. So it's a one-time investment, and your hardware needs a better RAM, a better graphics card. That is the one thing that I understand while I use it. Graphics card should be better for you to get a better output. So without a graphics card, sometimes the software doesn't open up. So that is a major investment that a person has to do. Hardware is one major investment that we have to do. Second one is software. Software is also another major investment because we get it as subscriptions, and for students it is free, for teachers it is free, whereas for contractors and for offices they have to get it by a small payment. So for offices and for contractors, that is a investment. they have to do an investment on the hardware and also the software. So which is like software, it's a recurring investment. Every year you have to pay for the software. Hardware is one time investment. Until and unless your system fails, maybe after 5 or 6 years, depending upon the usage of your system. And you need to have a good rendering machine so that you do the visualization right. So that is another investment that you will have. 2D, 3D you do in one particular machine and another machine for rendering. So that is another investment. And then finally the management softwares are very small ones. So mostly it will be in the form of, you will have an output in the form of Excel sheets and stuff like that. So that won't be a major issue. Only when you are understanding, I can give you a small understanding on that. 2 lakh square feet per floor, I have 10 floors, which is going to be 20 lakh square feet. I am running that in my system. Imagine you walking the 20 lakh square feet in one day. The same thing the system will be going through. So make it easier for it by having a better RAM and a better graphics card. So that is the investment that you will have to make, one time investment. Yeah, learning doesn't give you a big investment. You learn practice, because when I learnt it, nobody was using it. So I learnt it from one of my friends, and she taught me the basics. I started teaching. Every time I teach, I learn something new. And it can be like every time I teach. It's not like even the last time when I took workshop, I learned something new. So every time I teach, I learn something new. And so as you use it every day, you practice every day. Actually I tell my students what to do is, you sit and watch TV, but sit with your system, do something on Revit. Practice 20 minutes a day. Because like I give them an example. Your parents taught you to eat when you were kids. They made the food, they gave it with a spoon or they gave it with your hands, and they taught you how to eat it. So basically that is the major thing that you understood. Now you eat it like as though it is a muscle memory. So when you start working on Revit, get your muscle memory right. When you get your muscle memory right, things become easy for you. It's not only for this, it's for everything.
மேம்